just didn't know that I had it. Where do we want to start?
Number 3.
So let's first draw a picture of it. Is L congruent to M?
No.
Is K congruent to M?
Yes.
Always? Mm-hmm. Is line segment JK congruent to line segment KL?
Yes.
Now, without even looking at the figure or figuring out which two line segments those are, that's true, because that's the definition of a rhombus.
Yeah.
Is all line segments are equal. So the same for that. Same for that. Right? I mean, without even looking at the figures, there's no way they could name a line segment that wasn't congruent to another line segment, even if it was itself.
Yeah.
How about this one? JKM and LKM. Well, that's interesting. Did I label this thing wrong?
I don't know. It didn't give you very much guidance as far as labeling.
Seemed to me that I had only one choice. I could either go clockwise or I could go counterclockwise.
I don't think it.
Well, it doesn't make any difference in terms of this question doesn't make any sense. In other words, what is angle LKM? The way I labeled it, you can't tell.
Mm-hmm.
Had I gone counterclockwise, it wouldn't matter. In other words, it would have been JKLM. You still wouldn't know what LKM was.
Yeah.
So, and to me, I think that's the only choices for labeling it. When they tell you it's a rhombus JKLM, I don't believe I can go clockwise or counterclockwise, but I don't think there's any other way to label it, which makes question number 8 nonsensical. Unless I'm missing something. All right. For any rectangle, don't you label triangles clockwise? I guess with a triangle, it doesn't really matter, does it?
Yeah.
In other words, either one's the same. Do we really need to go over all of these? What's the answer to all of these?
Sometimes.
Well, that's always. In other words, anything involving angles is always. Anything involving opposite sides is always.
Yeah.
Now let's go through each one. In other words, that's always because all four of these angles are 90 degrees. but only opposite sides are congruent. So we have to make sure we have opposite sides. And again, it would not have mattered whether I went clockwise or counterclockwise. How about Wx and Xy?
Sometimes.
Sometimes. When that's true, what would it be? In addition to being a rectangle, it would be a square.
Square.
But squares are rectangles. So how about Wy and Xz? Ah, okay. Hold on. I was wrong. Wy and Xz, they're referring to the diagonal.
Oh.
Are these the same?
Yes.
Let's see if that makes more sense out of the previous problem. If they were saying angle angle JKM, that angle 1 is a congruent to LKM. That angle 2 for a rhombus. Is that true or not?
That's true.
Yeah. Only for a rhombus, not for a parallelogram. In other words, if I stretch that thing out so that it's no longer a rhombus, but that it's a parallelogram, those diagonals do not bisect. 1 is not equal to 2. But as long as it's 4 equal sides, it is. All right. Everything's perpendicular, obviously. Well, unless you're talking about the opposite sides, they would not be perpendicular. Is WY perpendicular to XZ?
No.
Sometimes.
Not sometimes, because it's not all the sides.
Only when it's a square.
Yeah, exactly.
Only when it's a square. But that is sometimes. And angle WXZ, angle 1, and angle YXZ, YXZ angle 2. Always or sometimes?
Always?
No? Again, only if it's a square.
Okay.
Only if it's a square. The way you can answer most of these type problems, in other words, I don't ever memorize it. What I do is I exaggerate the scenario. I draw my rectangles like that. Now, if this angle was equal to this angle, this would have to be a 45-45, and that would have to be the same as that. So I can instantly see both visually that this angle is not the same as that angle. But more importantly, actually is all I have to do is make it anything other than this side being equal to that one, and only isosceles right triangles have 45 and 45. So anything that doesn't have, in other words, anything that's not a square, those two angles are not going to be the same. Now, it is true that angle 2 is equal to angle 3 because it's a parallelogram and you have two parallel lines with a transversal. kind of quadrilateral is that?
Square. Square.
Okay. And do they want you to use all? In other words, it's also a rhombus. It's also a rectangle. It's also a parallelogram. I guess they would want you to use the minimally. In other words, only this is the only square. All right. I have the second page to this. You want me to pull it up?
Sure.
Question is where do I have it? Let me see. Quadrilateral B. This is it, isn't it?
I think so. Yeah, that's it.
Well, I'm a little confused here. We have a multiple choice question that apparently is not about this figure right here. Now I get it. Now I get it. All right. Do you want to begin any particular place on here? We have like 7 minutes.
Nowhere in particular.
Let's go down to the problems.
All right.
These kind of problems. So, given that picture, and all the markings on here that are not in blue are by somebody and they could easily be wrong. Okay, in other words, somebody marked this up and then they took a picture of it and sent it to me. So I have no idea if any of these are correct. In fact, it doesn't look like they are. No, I guess they are. Okay, let's see. We have a rhombus with two diagonals. DE, the measurement from there to there is 8. Okay, so all this information is in blue. What is DAC?
DAC is 50 degrees.
What is AED?
80 is 90 degrees.
What is ADC? Angle D and angle A have to be what?
Supplementary. I just subtracted 106 from 180 and divided it by 2 and got 37.
Well,
oh, angle D in general.
D in general is supplementary with angle A. This angle that's labeled 53 here, angle A is actually 106.
So it'd be 74.
Right. And always eyeball it. In other words, 37 was too small of a number. That's not a 37-degree angle.
Yeah.
And they're generally close enough that you can catch little mistakes by doing that.
Yeah.
Okay, that's actually an easy mistake to make. Had they wanted to know this angle right there, ADE, and oddly enough, they don't ask for that anywhere. Okay, what about side DB? Line 16? Yeah, how about AE? That's not so easy.
Yeah.
How do we get AE? We know that AE is half of AC, but we don't know AC. And just because we know DE, I wonder if that makes that a 6, 8, 10 triangle. You know what it is? This is an odd question. The only reason I know is that, here, this is funny. The one triangle that everybody knows is the 3, 4, 5, okay?
Mm-hmm.
But who knows what these angles are? Other than that's a right angle. You know what this angle is? You know what this angle is? Guess what they are? 37 and 53.
Huh.
So, these two triangles are similar, and that's 53, and that's 8, so this has to be a 6, 8, 10 triangle, which makes this 6, which makes AE is 6 and AC is 12. But there's no way for you to know that. And in fact, you have to use trigonometry to know that. And you have not had the trig to solve for that yet. That question should not be on here. That's very interesting. That is very interesting. That's a typo. Or else they left off a measurement. Maybe that was supposed to be labeled 10. Now, if you know that's 10 and you know that's 8, then you know that's 6. But if the only thing you know is that that's 53 degrees and that that's 8 and that's a right angle, then at the level of geometry you're at, you're not supposed to be able to figure out what that is. But when you take trig, you'll learn how to do that. Interesting. All right. Good place to stop, Cole?
Yeah.
Okay, and I have another geometry stove, but I'm not sure that is Dylan in your class or not?
Not in my class, no.
Okay, so it's not. This isn't necessarily the same material for him.
This is the same material. These are the exact same pages.
Okay.
All the geometry teachers follow the same curriculum.
Okay, cool. Thanks very much. Talk to you next week.
Thank you very much.
Bye-bye.